Welcome back once again. This is Mr. Spinks. We're in NAMS class and we are in section 2.3. This is the second video of section 2.3. We are going to be talking once again about sets as well as Venn diagrams and some of the relationships among them. Now we're going to start with two critical concepts that I'm pretty sure that you've heard of before, but at the same time I need to make sure. They are intersection as well as union. Starting off, the intersection of two sets is the set containing all of the elements common to both sets. Now, this indicates that the elements are going to be in both sets in this case, all right? So we're going to use a Venn diagram to help you to understand what this looks like. They have to be in both sets for it to be intersection. It's basically the area where the two circles are going to cross or where to converge. So if there are elements in A and elements in B, the elements that are in both are located in this center area, the shaded area in the middle, right there, are elements of both of them. That's intersection. To do intersection, we denote this as A with kind of like an N in between the A and B. That's intersection going on right there, common to both sets. Now we need to contrast that with union. As we're talking about union, the union of set A and set B is the set containing all of the elements that are either in A or in B. As we're looking, we will once again give you an idea of what this looks like utilizing the Venn diagram. So for union, it's either or. They can be an either or set. In intersection, it's got to be in both. Union, it's either or, so all elements that are elements of A or B, including the ones that are elements of A and B, are all going to be included in the union. This is denoted as A union B. So those are our ideas with union and intersection. We need to put them into practical application here. Starting off, we have a universal set, which has the elements 1, 2, 3, 4, 5, and 6. We have another subset of that, which is set A. It has 2, 4, and 6. B has 3 and 6, and C is the null set. Now, as we start here, I will warn you, every time I do this stuff, I look through my examples first and see if there's something in there that I'm going to need. I notice I'm going to need to know what A prime, B prime, all of the actual complements are. So I started out over here and actually wrote out what the complements were first. Now, you don't have to do this. It's just a suggestion. I'm going to start off with the complement of A because I'm going to use it later on. A's got 2, 4, and 6. Well, what is in A that's not in the universal set? I see 1, 3, and 5 that are in the complement of A. Moving on, the complement of B. As I look for the complement of B, B's got 3 and 6, so I think 1, 2, 4, and 5 are all in the universal set that are not in B. Finally, we have set C. Set C is the null set, and therefore all elements that are not in C are going to be all of them in the universal set, that being 1, 2, 3, 4, 5, and 6. Once again, this isn't necessary, but it's a good idea to set up everything you're going to need before you start. So let's go to our examples. Starting off, we have the intersection of A and B. The intersection of A and B is the set which contains all elements which are in A and in B. As I look at A and B, I only see one element that is in both of them. It is in 6. So the set which contains 6 is the intersection of both sets. Moving on. For B, we are going to set up the complement of A intersected with B. Well, right here is the complement of A. If I took the complement of A and intersected it with B, finding all elements that are common to both, I once again find one of them. I think 3 is the only element that is common to both of them. Therefore, the intersection is the set that has the element 3 in it. Moving on from there, A intersected with the complement of B. Here's the complement of B. We are going to see intersection, which elements are in both. So looking at A and looking at B, elements that are in both in this particular case, I see in A as well as in B prime, I see a 2 as well as a 4. So that means 2 and 4 are going to be the elements that are common to both sets. They are the intersection. Moving on to D. For D, we need A intersected with C. All elements that are common to A and C. Well, if you look at A, it has 2, 4, and 6, but C is the null set. It has nothing in it. So what elements are common to both? There are no elements that are common to both. The answer to this is the null set. Can be written as your empty bracket set, or you could also write it as a 0 with a line through, as the null set. Final one, A intersected with B complement. Well, I have A intersected with B right here. Here is A intersected with B. And if I want the complement of that, I want all elements that are in the universal set but aren't in the A intersect B. Well, the universal set is 1 through 6. What elements are not in A intersect B that are in the universal set? 1 through 5 are. I believe the answer to the bottom one is 1, 2, 3, 4, and 5. Pretty simple idea going on right there, guys. Last example that we'll do here is Venn diagrams and the same idea here, reading it off of a Venn diagram. So, reading this directly off of the Venn diagram, as we look here, we are looking for elements that are in A. And in looking for elements that are in A, I look at A and I see 1, 2, 3, or 1, 2, 5, as well as 4. Don't forget the 4. It's also in A. So 1, 2, 4, and 5 are all in A. Next up, they ask for the universal set. Well, the universal set is all elements within the box, all of them, including those in both circles as well as those outside of the circles. So the 1, the 2, the 4, the 5, the 3, the 8, the 9, the 6, and the 7, they're all in the universal set. That would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Moving on to our next example. Our next example is the union of A and B. The union of A and B is all of the elements in A and B. All of them can be included because it's common to, or those that are in either or set. So we have a 1, a 2, a 3, 4, 5, not 6 and 7, they're outside, but we do have 8 and 9. Moving on from there, the next example is asking me for the complement of A union with B. Well, the complement of A is all of the elements that are not in A. So for the complement of A, I'm going to get rid of A, because that's the complement of A going on, all elements that are outside of A. If we union that with B, elements that are members of both sets here, well, in A complement and B are all of the rest of them that we have right here in either or. That being, in this case, 3, 6, 7, 8, 9. Moving on from there. Next example is B complement. As we look for B complement, in looking for B complement, well, here's B. B complement is all elements that are in the universal set that are not in B. So I'm going to strike out everything in B, and therefore everything else that's there, the 1, the 2, the 5, the 6, and the 7, are all in B complement. Last one, intersection of A and B. As we look for the intersection of A and B, we look for the elements that are common to both sets. Common to both sets, I only see one of them common to both sets. It would be this 4 here in the middle. So for my intersection of A and B, I think that is just the number 4 in this case. Very important. We'll have a quiz over this shortly, so make sure you're good with the ideas of union, intersection, complements, and Venn diagrams.